So on to approach D, which is the intensive lake characterization, or the TransSect project, as I called it. Kind of started with the question and with plotting up some data. So this data is from 2018 from the North Sea Slap site, which is the diamond right here. It is fluoroprobe blue-green algae concentrations at the open water at the North site, which is also where the buoy, where that platform is deployed as well. But this was in 2018, and then also plotted is the raw water microcystin toxin concentrations from the city of Syracuse, thanks Rich, plotted on the same graph. And it kind of just started as a question that we had, and we saw a similar pattern in other lakes that we're seeing raw water toxin hits, is we saw a little bit of an increase in that blue-green chlorophyll in the open water, and then a pretty big increase prior to a lot of these really low. And in the raw water, I'll emphasize that they never went above the Department of Health guidance value in finished water. But we saw some things that we're interested in. Sea slap, as I mentioned, is biweekly. So wonder if we had another sample rate in here, could we tell when the blue-green in the open water was starting to ramp up? Were we getting shoreline blooms around that point, toxins in the drinking water? So it brought up a lot of questions to us is, well, what's going on in this lake? What's going on in the different areas of the lake, in the open water, and the shoreline, throughout the water column? And that's how this project was kind of born. And so we decided to take a look at how can we characterize over time, over vertical space, and at different depths in the water, and spatially at multiple locations in Skaneateles Lake to try to help answer some of those questions. Recognizing there's a lot of those questions, and we're hoping this project could provide some really good, high-quality data that could not only be used to advance the broader advanced HABs monitoring, but also advance any modeling work that's done as part of the 9-element plan. So you can see the field parameters that we took with our clarity, and then also with our multi-parameter probes. A lot of chemistry, a lot of nutrients, including extracted chlorophyll. We took toxins at a lot of different places, and also ran the fluoroprobe for total algae and algal group classification, which is a lot of some of the data I'll be talking about today. And here are the site locations. As I mentioned, here is, we're primarily in the north end of Skaneateles Lake. We'd love to do transects across the whole lake. This already took us a whole day when we were out there, so we recognized our time limitations and kept it to the north end of the lake. Just to point out, this SKS1 is the North Sea Slap site and is also where the USGS platform is. So it's a really great way to fill in any of our knowledge gaps with what is happening. We have real-time data at that buoy, and also a lot of chemistry sampling there as well. So here's kind of a cross-section snapshot, similar to what I showed you before, showing all of the site locations in Skaneateles. SKLT1 right here is the furthest south, the deepest location at about 65 meters, and then working our way north towards LT4, which is right off the pier in the village. And about half the sites we took chemistry grabs, which are these gray circles. We did a 0.5 meter integrated for the surface, 2 meters for the epilumnetic sample, thermocline, depending on where the thermocline was, or if there was a thermocline, hypo, and then we tried to get as close to the bottom as possible to see if we could pick up any of those nutrient fluxes that I know some people have been talking about today. So you can see it was a pretty intensive project. We were out there all day collecting samples and doing profiles. There was a lot of field filtering, but it was a lot of fun, and I think we collected some pretty cool data. So before I get into some of the data, I just wanted to showcase some of the pictures. This is a combination. We also did this on Canandaigua Lake, so some of these pictures are from Canandaigua. But this top one is our 2 field instruments, our YSI XO2 and our algae torch, which we bound together to do vertical profiles. Here we've got some Aseki disc clarity readings. We're field filtering for SRP. Clarity, this is our intern over the summer who's doing the profiles and, you know, taking notes. This is what we did our integrated sampling for that half-meter integrated. And again, it's not all sunny and fun like it is in this picture. This was a picture on Canandaigua where I think I would have been more dry if I jumped into the lake. But it was still, again, a lot of fun, and we got a lot of really great data out of it. So here are some very preliminary findings. This is from the FloraProbe data that we collected, so for algal composition. This is taken at site LT4, which, as I mentioned, is right near the village pier. And this is at the surface, which is that half-meter integrated I mentioned, and the epilimnetic sample, which is at 2 meters. So we went out about monthly until things started to ramp up in September, which we added another sample in September, and then we went out twice in October. So monthly and then bi-monthly as we got into HAB season. So I just wanted to point out a few things. Here, you'll notice kind of the seasonal progression of the algal dominance group. For those that live on the lake, you might have remembered in early August, the lake probably looked really green. The clarity dropped significantly. We actually had a really significant diatomid green algal bloom that we picked up in early August. So the brown is the diatoms, the green is green algae, the pinkish purpley is the cryptos, and then cyanobacteria is actually that blue-green color appropriately. So interestingly enough, we tend to see higher concentrations in the surface than the epi, so a lot of this is concentrating on the surface. We're also seeing that species shift throughout the calendar year. Again, mostly dominated by greens and diatoms in August, but September 4th is when we start to pick up that cyanobacteria concentration, which again you can see is a little bit higher in the surface than the epi. Interestingly enough, Frank, when was the first bloom? September 2nd or 3rd?
3rd. Although
so
it says 2nd on the DEC site, I don't know why still. But
I'll check on that.
Sorry.
So we were out there a day or two after, depending on who you. So you can see, you know, right at the village, we're starting to see that ramp up of cyanobacteria. And we see it consistently throughout September, and we see it start to drop off in the beginning of October and completely drop off by the end of October. And again, you see the same characteristics in the epilimnetic samples, whereas those cyanos tend to start to decrease later on, fully dropping off by the end of October. So this is another way to look at it. So, and I just want to point out that this is just an example of the data we collected. This is one site. We have this for all dates at every site. I just wanted to highlight a couple examples of the data we collected. So here's another example. So this is at all the sites. So you can see the sites on the bottom here, starting here on LT1, which is the furthest south, moving northward, getting more shallow as we work towards the village. And here, just starting in September 4th, September 17th, October 3rd, and October 28th. We also see a few interesting things here. First of all, in early September, we see higher concentrations actually in the village here at 4 than in the open water. We see higher concentrations of both total chlorophyll and the cyanobacteria, and 3 W's at the site right next to the country club, actually. So it's a nearshore site here, nearshore site here. We're seeing higher concentrations at those 2 locations nearshore, which coincided with the bloom notifications that we received from SLA and others. Interestingly enough, mid-September, we got a shift in the distribution of the cyanobacteria and total chlorophyll. So instead of it being mostly concentrated to the nearshore, we're getting more total chlorophyll and quite a bit of cyanobacteria in the open water in those really deep locations. And when we were out actually on September 17th, we noticed a lot of streaking early in the morning in the open water, and we heard there were no bloom reports along the shoreline that day. DEC was the only one that submitted a bloom report on September 17th. So it's just interesting to see, we kind of see similar results in early October as well, where you again expect to see higher concentrations of cyanobacteria along the shoreline. Again, we're mostly getting bloom reports there. we have more people looking there. We have the trained volunteers who are looking there, but as you can see, we're having higher concentrations of total chlorophyll and higher concentrations of cyanobacteria in the open water. So what does this mean? We're not sure yet, but it's really interesting to be able to see that spatial distribution of cyanobacteria. Again, this is in the surface water, so in that top half meter integrated, but we have these results for every depth that we took. But again, I can only present so much today. So again, lastly, in October, we saw the drop-off, no cyanos, but still, interestingly enough, higher concentrations of chlorophyll in the open water than in near shore. So I just want to say this is a small snapshot of this type of data that we collected. We collected chemistry samples, which we're still getting the results back to analyze those. And we also took toxin everywhere microcystin toxin everywhere we took chemistry samples, and those are still being analyzed as well. This is part of just the broader advanced monitoring program, and we're excited because of the platform being at one of our locations. We're going to be able to really pair up some of the data that we've collected throughout the water column and take a look and see what the platform is reading. But I just wanted to show you one last slide, which we've talked a lot today about the seiches that occur. Well, we actually happened to pick one up when we were out doing sample. This is our profiles for all the sites, so both the chemistry and the field-only sites. And you can see this is temperature here on the left, and here is, this is chlorophyll and turbidity. The green is total chlorophyll, the blue is phycocyanin, and the brown is turbidity. And you can see we still got some cleaning up of the data that we need to do. This is all preliminary, like this Skaneateles is probably when we hit bottom, but it's just interesting to know here at the southern end of the site, the thermocline is around 10, looks like maybe 8 or so. By the time we got down to LT2, which is just south of the country club, we were measuring the thermocline around, I don't know, what is that, 13, 14 meters, so almost like a 6-7 meter difference between the thermocline. And that's probably over the course of maybe 2 hours at most, and probably less than a mile difference between the two locations. So it was pretty cool to pick up that seiche that we think that is, this was July, in early July. So it was cool to be able to pick that up with our field instruments. And we saw some cool patterns in chlorophyll, but again, we still need to do some QA/QC of the data, do some post-calibration. So this is all preliminary, but just again, the type of data that we collected. And so I just want to again highlight, this is one part of the overall advanced monitoring program, and we're really excited to start to get into the data this winter and spring and start to work closely with USGS to really understand what the platform's saying, what the data that we took are saying. I'm not familiar with any other study that's at least been done on the Finger Lakes that took this amount of data, chemistry data over time, over space, and over depth in the water column to really try to get a really good understanding of what was going on. So that's the Advanced HABs monitoring program. I want to switch gears.